us working, Wait, what the?
Note, most of this video uses Google Colab as an environment. Simply go to colab.research.
Okay, that works.
Search.google.com, create a new notebook, and that's all you need to set up. Now, it's some weird convention that whenever anyone is using a new programming language or environment, we generally try to output the text hello world in that programming language. So we'll do that in Python by clicking in here, and we will write print for print. We will write a round bracket like this, a double quote, and then the text hello world. We'll put another double quote, the other round bracket, so it kind of sandwiches it in like that. Hold shift, press enter, and that outputs the text hello world. So the reason that we needed these double quote things is because this is how we signal to Python that whatever's between it is text. And so you can see that it's outputted, it doesn't actually have the quotations. And that's because we are using these things to tell Python that between them it is text. And so what actually gets outputted is just the text itself, not it with the quotes. If you did want the quotes, well, you have to tell Python that. It's like, hey, I'll use these quotes to say that this is text, and then I'll have quotes in here. See a quote there and a quote there. Well, that shows, hey, I need the text of quote, hello world quote, and so it prints that for you. Just in like that, hold shift, press enter, and that outputs the text hello world. So the reason that we needed these double quote things is because this is how we signal to Python that whatever's between it is text. And that's because we are using these things. In Python, there's really no difference between the double quotes and the single quotes. And I can show you that if I instead just remove these double quotes entirely. So that's going to do the same thing at the beginning, because the single quotes also are saying Python, hey, whatever between these two things, that is text as well. So we just get outputted hello world. And so if you wanted to display double quotes in the output, well, we could put that within here, because if I have double quote and then double quote between the single quotes, well, the single quotes are still telling the Python what's between this is text, and so okay, the double quotes, I'm going to treat that as text. If I hold shift, press enter, it outputs it with the double quotes. Python printing is pretty powerful. You can even put numbers in here if you wanted, because it just treats whatever letter on the keyboard or number on the keyboard you put in there as text. And so if I wanted to do hello world and then 7, I'm going to remove those double quotes because it's a little annoying to look at. Hello world 7, it's totally happy with that. You put in the number, it treated it as text, and so it can output both text, like in letters, and numbers as well. A big reason why I use Google Colab instead of some of the other environments like VS Code or PyCharm for most of my coding is that we don't actually need the print function to print things in Colab. If you wanted to just print all of this text, well, if you copy that, paste it in a new cell here, and then ran that, well, it's going to output that by default for you. That is because it was on the last line. If we instead had, say, two different things, we'll put up here, it's going to do hello world, I'll put 8. It technically is going to go top to bottom, it's going to run this, but we didn't print it, so it's not really going to do anything with it. It's basically just going to forget that it even happened. Hello world 8, and then at the bottom, well, I left it as the last line here, and so it again, if I ran that, it is going to output that same thing back. Notice that if you print it this way, it is going to include the quotes, so they show up there, but if you print with the print function, it is not going to print the quotes. It's not really a big deal, it's just a small nuance of how Colab works. You don't have to worry about that. So you'll probably see me flip swap between using the print function to print and just leaving it at the last line to print. There's times when you'd want to do each, and I'll choose between. Now, you or I would think of this as text. Hello world 7 is text. Hello world 8 is text. A password, your name or sentence, whatever you want to put in there, we think of it as text. But to Python, it actually thinks of this as what we call a string. So this is actually, in Python context, a string of hello world 7. So if I were to copy this and I were to put it down here, similarly to how print takes whatever it is and then outputs that, well, type, this is going to output, not type as in type on the keyboard, the category of something. And there's a bunch of different Python categories, and we'll look at those. Type, and then just that same text there, hello world 7, it doesn't return text, it returns str, which is short for string. So it's saying that this text here, or the string, this is the string of hello world 7. You might be wondering what's the difference. And it was there, age is spit. But we don't see the high down here. We don't see that it printed high, because normal division symbol, if you do that, what you do, you will return a floating point number. Even if the fraction looks out perfectly, 1 goes into 1 exactly once, it does not return the integer 1, it returns the floating point of 1.0. So it's still equal to 1, but it is returning a decimal number. And if you instead did it with floating point numbers, you had, say, 3.2.
Hello there, in this tutorial series, Hello there, and welcome to the first part of this class. If I now work this, we get 6. These are the only after something still inside of the function. We are getting, in our case, with fundamental concept. Code in Python in basically any programming language is always executed. Names a name for a variable, but it will do that. Hello there, in this tutorial series, you are going to do everything from anything to everything. And just to get started, I will have 2 main topics. Number 1, why choose Python in the first place? Number 2 is what we are about to explore. First of all though, why choose Python in the first place? And for that, you have to be aware that there are hundreds of programming languages. And usually the language name works.
What's going on, everybody? So alright everybody, so we are moving on to typecasting. Typecasting is the process of converting a variable from one data type to another. We have various numbers, but we treat them as characters. Now we have... What's up everybody? In this video I'm going to teach you everything you need to know to start coding with Python. I've also included 20 different hands-on projects to help you learn. You can find the entire list in the description of this video. Our final project will be a weather app that fetches real-time weather data from an API. Even if you've never coded anything in your life before, I'll walk you through the basics, the ABCs of programming. If that sounds good to you, then I encourage you to sit back, relax, and enjoy the show. This course doesn't cost you anything, but if you would like to help me out, you can help increase its reach by hitting the like button, leave a random comment down below, and subscribe if you'd like to be a fellow pro. Thank you, I appreciate it. I don't like boring introductions, so I say we just jump right in. There's 2 things we'll need to download. The first is a Python interpreter to convert our written code to machine code. We're going to head to python.org, go to downloads, and download the latest version. We will open this executable. If you're on Windows, you'll want to check this checkbox, add Python exe to path, and we will install now. The setup was successful, and that's all you need to do to download the Python interpreter. The second to download we'll need is an IDE, an integrated development environment, basically a place where we can write code, or Alright everybody, we are moving on to variables. A variable is a container for a value. There's 4 different data types we'll discuss. Strings, integers, floats, and booleans. Yes, I know, that's a silly name. A variable behaves as if it was the value it contains. Each variable should have a unique name. Let's say we have a variable of first name. To assign a variable, you use the assignment operator of equals. For text, a string is a series of text. This can be double quotes or single quotes. My own preference is double quotes. Why don't you type in your first name? This variable of first name will behave as if it was this value, this series of characters. So to demonstrate this, I'm going to print my first name variable. So place it within a print statement without quotes. That will print your first name.
Wait,
now, I don't want this within quotes.
Actually?
And we'll just have to give it a moment. Okay, the setup is now complete. I'll check this checkbox to run PyCharm when we close this window. After opening PyCharm, we're going to create a new project. You can rename your Python project. I'll keep it as is. You can select a location. Again, I won't change that. You can create a sample welcome script, but for this tutorial, we won't. Let's select the latest Python version and create our new project. In the menu to the left, we're going to create a new Python file. File, new, Python file. Let's name this file main. But really, you can name it anything. And select Python file. Python files end with the py file extension. We should have our main Python file within our Python project folder. Now we're going to print something to the console window. Within our main Python file, we're going to write a print statement. So type print, add a set of parentheses. Between the set of parentheses, we will add a set of double quotes to print something, or single quotes, either one. My own preference is double quotes. Normally in a programming tutorial, the instructor would tell you to print something such as hello world, but we like to be different here. Instead, think of your favorite food. In this case, I like pizza. I will print, I like pizza. To run our Python program, we will click this green arrow to run our main Python file. We should have a console window that displays our output. I like pizza, or whatever your favorite food is. Let's print another line of code. Let's print, it's really good. By adding a second print statement, we are printing a second line of code. Now we'll discuss comments. The Python interpreter doesn't output comments. To write a comment, you use a pound sign. I like to call this a hashtag. My comment will be, this is my first Python program. Comments are used as notes for yourself or for other people reading this code. If I were to run this code again, this comment is not displayed to the output. We still have, I like pizza, it's really good. Alright everybody, so that is your very first Python program. And in the next topic, we'll discuss variables. Alright everybody, we are moving on to variables. A variable is a container for a value. There's 4 different data types we'll discuss. Strings, integers, floats, and booleans. Yes, I know, that's a silly name. A variable
Okay. Let's see. Okay, that works.
Behaves as if it was the value it contains. Each variable should have a unique name. Let's say we have a variable of first name. To assign a variable, you use the assignment operator of equals. For text, a string is a series of text. This can be double quotes or single quotes. My own preference is double quotes. Why don't you type in your first name? This variable of first name will behave as if it was this value, this series of characters. So to demonstrate this, I'm going to print my first name variable. So I'll place it within a print statement without quotes. That will print your first name. Now you don't want this within quotes, because then you're literally printing the word first name. You could use your variable along with some text by using what is called an F string. That's the easiest way to display a variable. So you type F, then a set of quotes. The F means format. So let's say the word hello, then we will add our variable. We will insert our variable into this text when using an F string. To do that, you need a set of curly braces, then insert your variable. So the result is hello, whatever your first name is. In my case, bro. Let's create another variable. Let's say we have a variable of food. Food equals, think of your favorite food. For me, I will type pizza. Let's print the following. You.
Okay.
Like, add a placeholder. Again, I'm using an F string. Our variable of food.
And then print statements. Okay.
Hello, bro. You like pizza. Let's create an email. Use your own email or make up one. Let's say my email is bro123@fake.com. Then let's print our email. Your email is, add a placeholder, display our email variable. Your email is bro123@fake.com. So these are strings. I'm going to add a comment that these are strings. A string is a series of characters. They can include numbers, but we treat them as characters. Now we have integers. An integer is a whole number. An example of this could be somebody's age. How old are they? According to my YouTube statistics, many of you are between the ages of 18 through 24. Let's say that I'm 25. Let me zoom in a little. Your integer should not be within quotes, because it would be a string then, technically. If I would like to work with this variable, again, I'll use an F string. Let's say you are, add a placeholder, display our age variable, years old. You are 25 years old. Another example of an integer could be a quantity. You are buying a certain amount of something. Maybe I'm buying 3 items. I wouldn't have half an item. This would be a float technically, rather than an integer. We are buying 3 of something. So let's print the following. You are buying, add a placeholder, display our quantity, items. You are 25 years old. You are buying 3 items. Another example of an integer could be an amount of people. Let's say num.
Oh no, come on.
What's going on, everybody? So in today's video, we're going to create a working weather app that fetches. Alright, everybody, we are moving on to. Alright, everybody. And again, make sure they're not within quotes, because then technically they would be a string. Integers we can use in arithmetic expressions. If they were strings, we couldn't. Then we have floats. Float means floating point number. A float is a number, but it can.
Okay,
contains a decimal portion.
Hold
An
on.
example, because that your class has 30 students. Those are integers.
Hmm. Hold on.
They're whole numbers. You are 25 years old, buying, at a placeholder, display our quantity, items.
Oh. Hmm.
You are 25 years old, you are buying 3 items. Another example of an integer could be an amount of people. Let's say num of students, like a classroom. There are 30 students in our class. Then we will print, your class has, at a placeholder, students. We will display the number of students, num of students. Your class has 30 students. Those are integers, they're whole numbers. And again, make sure they're not within quotes, because then technically they would be a string. Integers we can use in arithmetic expressions. If they were strings, we couldn't. Then we have floats. Float means floating point number. A float is a number, but it contains a decimal portion. An example would be a price. What is the price of something? $10.99. Let's print our price. Print, I'll use an F string. The price is, at a placeholder, display our price. The price is $10.99. Let's precede our placeholder with a unit of currency. I'll pick American dollars, but feel free to pick something else. The price is $10.99. So floats contain a decimal portion. What about a grade point average, GPA? Let's say my GPA is 3.2. Then I will print, your GPA is, display our GPA. Your GPA is 3.2. What about a distance? A distance can contain a decimal portion. 5.5 kilometers maybe. Then I will print, you ran, at a placeholder, display our distance, then I'll add km for kilometers. Or you could add mi for miles, but I'll stick with kilometers. You ran 5.5 kilometers. Okay, then we have booleans. A boolean is either true or false. Let's say we're a student. Is student equals. If we are a student, we can say that this is true. True starts with a capital T. If we weren't a student, let's say we graduate, we could say that this is false. Again, the first letter is capital. Booleans only have 2 options, true or false. So let's say that I am a student. Then I will print, are you a student? And we will display our Boolean value of is student. Are you a student? That's true. With Boolean values, we really don't output them directly. You're more likely to see them used internally within a program, such as when working with if statements. This is a topic we'll discuss in the future, so don't worry. You may see if is student. If this variable is true, then we will print the following. Now, we don't need to use an F string. We're not going to insert any variables. You are a student. If this were false, we can add an else clause, where we will print, you are not a student. Our variable is student is true. We will print the if statement. You are a student. If this were false, we will print whatever's within else. You are not a student. Let's think of a few more examples. Is something for sale, like a car or a product of some sort? Let's say that is true. I'll write another if statement. If for sale, if this variable contains true, we will do the following. Let's print that item is for sale. Else, if it's false, we will print something else. That item is not available. For sale is set to true. this variable is true, it will print that item is for sale, else if it were false, we print that item is not available. One more example. Let's say we have a Boolean variable of is online. Is somebody online? I set that.
Okay. are they? Let's write some statements here.
That's true. If is online. If that's true, we will print you are online. Else we will print you are offline. Is online is that true? We will print you are online. Else if it were false, we print you are offline. Alright everybody, so those are variables. A variable is a reusable container for a value. There's 4 basic data types for beginners. A string, which is a series of text. Integers, which are whole numbers. Floats, which are numbers, but they contain a decimal portion. And booleans, which are either true or false. They're binary. Your assignment in the comment section is to post 4 variables. Post a string, an integer, a float, and a boolean. Try and think of a unique example if you can. And well everybody, those are variables in Python. Alright everybody, so we are moving on to typecasting. Typecasting is the process of converting a variable from one data type to another. We have various functions to convert a value or variable to a string, an integer, a float, or a boolean. Let's create some variables. We will create a name variable, type in your full name. An age, make up some age. A GPA for grade point average, let's say minus 3.2. And a boolean of is student. Are we currently a student? Let's say that's true. Now you actually could get the data type of a variable or a value by using the type function. Then pass in a value or variable. However, when I run this, there's no output. So I need a print statement. We will print what is returned by the type function. Get the type of our name variable, then print it. So our name variable is a string, str. Our age variable is an integer, an int. GPA is a float. Is student is a boolean. Using these typecast functions, we can convert from one data type to another. Here's how. Let's start with something simple. Let's convert our GPA to an integer. Currently it's a float. I will reassign a GPA, use the int function to typecast to an integer, then pass in my GPA. At the end, we will print our GPA. If we typecast 3.2 to a whole integer, what would the result be? A whole integer of 3. Truncate the decimal portion. Let's convert our age to a floating point number. We will reassign our variable of age, use the typecast function of float, then insert our age variable. Let's print our age variable, and it should be a floating point number, 25.0. Now we'll cover strings. Let's typecast our age to be a string. Age equals, call the typecast function of string, str, pass in our age variable. So the result is still going to appear the same, 25. However, it's a string, not an integer. And to prove that, I will enclose my age variable with the type function. The type of variable age is a string. It would be the same as if we're taking this number and enclosing it within quotes. So this would make a difference, because let's say that I add 1 to age. Age plus equals 1. Well, we would get a type error. We can only concatenate strings, not integers, to a string. However, if I were to add a string of 1 to the end, we would be using string concatenation. So let's say it's my birthday.
Okay.
Did I add 1 to 25? Well, since we're working with strings now, the result would be 251. I am 251 years old. So strings and numbers behave differently. With numbers, we can use them within arithmetic expressions. Strings, not so much. We will take our name variable and typecast it to a boolean. Name equals, call the typecast function of bool, pass in our name variable. This has an interesting result, so I'm going to print name. Booleans are either true or false. If I typecast my string of text into a boolean, that gives me true. Now it really doesn't matter what I write here. If I were to change my name to a single character such as B, this would still be true. If our string variable was empty, there were no characters within it, that would actually give us false. We could use this to check to see if somebody enters in their name or not. If somebody types in their name, then we typecast it to a boolean. If somebody skips entering in their name, that would return false. We could reprompt the user to enter in their name again. Alright everybody, so that is typecasting. It is the process of converting a variable from one data type to another. This is especially useful with handling user input, because user input is always a string. There may be at times where we want to convert it to an integer, a float, or a boolean. And well everybody, that is typecasting in Python. Alright everybody, in this topic I'm going to show you how we can accept user input in Python. We use the input function. It's a function that
Okay. Just get that in here.
accept user input. What we will call the input function. When I run this program, we need to enter in data to our console window, like so, then hit enter. However, we need a prompt. We need to tell the user what we want them to type in. So let's ask a question. Our prompt will be within quotes. Let's say, what is your name? Let's try this again. What is your name? I can type in something. Why don't you go ahead and type in your full name? And hit enter. Now with this input, we're not quite doing anything with it. The input function is going to return some data as a string. We can assign it to a variable if we would like. Let's create a variable of name. Name equals our user input. Then once we have our name, let's print a message. I'll use an F string. We will print hello, add a placeholder, then insert our name variable within that placeholder. Let's try this. What is your name? Type in your name, hit enter, hello, whatever your name is. Let's try a different name. I will pick SpongeBob. Many people are familiar with SpongeBob. Hello, SpongeBob. This time, we will ask a user how old they are. Let's assign a variable of age equals accept some user input. We need a prompt within quotes. How old are you? Once we have our age variable, let's print I'll use an F string. You are, add a placeholder, our variable age. Years old. What is your name? Type in your name. How old are you? Let's say that I'm 25. Hello, whatever your name is, you are, whatever your age is, years old. Alright, so let's say that it's our birthday. Before we print our age variable, let's say, happy birthday. Since I'm not inserting any variables within this print statement, this doesn't need to be an F string. You'll want to use an F string if you want to insert variables, before we display the user's age.
Okay. What happens if let's say,
Let's take the user's age and increase it by 1. We can say age equals age plus 1. But there's one problem with this. Type in a name. How old are you? Type in an age. And we have a problem. We have a type error. We can only concatenate strings, not integers, to strings. When we accept user input, we store that input as a string. Before we increment our age by 1, we'll need to convert it to an integer. We can't normally use strings within arithmetic expressions, but we can do that with integers and floats though. After we accept some user input for our age variable, we could take our age variable and typecast it as an integer, which we talked about in the previous lesson. So let's say age equals our age after we typecast it, then increment it by 1. So type in your name, type in age, and we get this message. Hello, your name, happy birthday, you are, whatever your age is, years old. So strings we can't normally use.
click for the next purpose.
Expressions. We would have to typecast it to an integer or a float. However, we could condense some of these steps. We're taking up an extra line to typecast our age as an integer. What we could do instead is that when we accept our user input, we can enclose the input function within a typecast to int, and that would work the same. Type in your name, type in an age, and this works the same. And it takes less lines of code, and is more readable, I would say. When we accept user input, it returns that input as a string data type. Then we just have to typecast it to another data type if we need to, and in this case for age, we do. Now we'll go over a couple exercises, because it's important to practice what you learn. In this first exercise,
Okay. So you would have
length by the width. So let's say area equals our length variable. Now to use multiplication, you use an asterisk. We'll discuss different arithmetic operators in the next lesson. So we have length times width. That is the area. I'm going to print our area because I need to test something. Enter the length, let's say 5 inches, 5 centimeters, doesn't matter. Enter the width, 6. We get a type error, can't multiply sequence by non-integer of type string. When we accept user input, it returns a value of the string data type. We can't use those strings in arithmetic expressions. We're multiplying the length times the width. We would need to typecast them as an integer or a float. Since we're working with basic geometry, such as calculating the area, let's do float. So let's typecast our user input as a float for both length and width. Okay, let's try this again. Let's say 5 times 6.
Let me give that a try, actually. So you told. How about I just wait, what the fuck? Oh my god.
the area that's returned to us is 30.0. This result contains a decimal. It's a floating point number, a float. So when we print the area, I'll use an F string this time. The area is, I'll add a placeholder, display our area variable. Let's add a unit of measurement afterwards. I'll pick centimeters. Now, since we're working with areas, if we would like to technically be accurate, so we can say to the power of 2, or we could add a superscript. So if you would like superscript 2 and you're on Windows, make sure numlock is on. Hold Alt, then type on the numpad 0178. So we have a superscript of 2. Again, it's not really necessary for this lesson. I just think it'd be cool to include it, because then it's technically accurate. Superscript 2 and you're on Windows, make sure numlock is on. Hold Alt. Type on the numpad 0178. So we have a superscript of 2. Again, it's not really necessary for this lesson. I just think it'd be cool to include it, because then it's technically accurate. Alright, let's say that the length is 6.1, and the width is 7.
Let's see if that works.
The area is 43.92 centimeters squared, because we're working with areas. Let's cover a second exercise. This time, we will create a shopping cart program. Exercise 2. We're going to create a shopping cart program. We need 3 variables: an item, a price, and a quantity of those items. We will create a variable of item. We will accept some user input. What item would you like to buy? What are we trying to purchase? We'll keep the data type of the user input as a string. Then we need a price. What is the price of each item we're buying? Use the input function. What is the price? A price should be a floating point number. For example, we might have dollars and cents. We need a decimal. So let's typecast our input as a float. Then a quantity. We will accept some user input. Our prompt will be, how many would you like? Quantities, they should be whole numbers. Let's typecast our input as an integer. Then we will have a total. What's the total that we have to pay? So let's take the price of each item, use an asterisk for multiply, our quantity. Then let's do a test run. Let's print our total. What item would you like to buy? Let's say a pizza. What is the price? $10.99. How many would you like? I would like 5 pizzas. And our total is 54.95. Let's say that before we display the total, let's print the following. I'll use an F string. You have bought insert a placeholder, display our quantity, X, item, or items, I'll add /s. Then we will print, I'll use an F string again. Your total is, display our total. What item would you like to buy? I would like to buy a pizza. What is the price? $10.99. How many would you like? I would like 9 pizzas. They're all for me. I'm gonna eat all of them. You have bought 9x pizzas. Your total is 98.91. Let's add a unit of currency before this. Unit of currency before displaying the total. I'll pick American dollars. I would like to buy pizza. What is the price? $9.99. How many?
Okay. I like it.
many would you like? I would like a dozen pizzas. 12. You have bought 12x pizzas. Your total is $119.88. Alright everybody, that is how to accept user input in Python, and we've covered a few exercises. In the next topic, we're going to create a Mad Libs game, and that is how to accept user input in Python. Alright everybody, in this video we're going to create a game of Mad Libs, not because we have to, but because I want to. It would be a good exercise for us, just so we're more comfortable with accepting user input. If you're not familiar with Mad Libs is a word game where you create a story by filling in the blanks with random words. So we're going to create a story template. The story is going to be missing some components. We will fill in those components with random words that we type in. Here's a story that I've written. Myself. Print. Use an F string. Today I went to a insert a placeholder zoo. For our placeholder, we'll insert an adjective. We'll insert a variable named adjective. Adjective 1. You're going to get an English lesson today too. An adjective is a description of something. So for our zoo, adjective 1 could be expensive, large, dirty. An adjective describes something. We'll fill this in when we accept user input. For our second print statement, let's print the following. In an exhibit, I saw a placeholder. We'll include a noun. Noun 1. A noun is a person, place, or thing in English. Maybe a gorilla named Harambe, for example. Print is an F string. Let's say our noun 1, whatever this is, we can reuse variables. Was, we will create a second adjective, adjective 2. We will be describing whatever noun 1 is, this person, place, or thing. And we will insert a verb, verb 1. A verb is an action, such as running or eating. Then,
Huh?
for our last statement, let's print, I was. And placeholder, we'll create adjective 3. Adjective 3 will describe us. Now we're going to fill in these variables by accepting user input. We're going to fill in adjective 1. We'll accept user input using the input function. Enter an adjective. We're going to add a reminder that an adjective is a description of something. Then we need noun 1. Noun 1 equals input. Enter a noun. A noun is a person, place, or thing. Then we have adjective 2. I'll just copy adjective 1, paste it, change 1 to 2. Then a verb. Verb 1 equals input. Enter a verb. I want verb 1 to be in current tense. I'll ask the user to end the verb with ing. Enter a verb ending with ing. Then it's current tense. Our person, place, or thing of noun 1 is currently doing something, such as eating. And then adjective 3, I'll just copy one of these adjectives. Adjective 3 equals input, enter an adjective. Okay, and then we are ready to run this. Enter an adjective. An adjective describes something. I will say suspicious. And then we are ready to run this. say suspicious. Or some kids like to say sussy, or sus even. I've also heard of kids nowadays using the word skibbity. Feel free to type in whatever you would like. It is your story after all. I'm gonna say suspicious. Enter now a person, place, or thing. I like to poke fun at Mark Zuckerberg, so I'm gonna say my person is Mark Zuckerberg. Enter an adjective. That is a description. Angry.
Okay, steady slots. Okay. Weird. Okay. Just change this a bit actually.
Enter a verb ending with ing, so it's current tense. Screeching. Enter an adjective.
Oh, where are you from? Not a major, so.
Happy. Here's my story. Today I went to a suspicious zoo. In an exhibit, I saw a Mark Zuckerberg. Mark Zuckerberg was angry and screeching. I was happy. That's our game of Mad Libs. It's a word game where you create a story by filling in the blanks with random words. Also, post the output of your Mad Libs game in the comment section down below because I really want to read them. I want to see what you guys came up with. Well, everybody, that is a Mad Libs game using Python. Hey everybody, in this video I'm going to show you all of the different math that we'll need throughout the rest of the series. I have a lot to cover, and I'll split this video into different sections. We'll cover some basic arithmetic operators, built-in math functions, a few functions for the math module, and then a few exercises. Be sure to look at the timestamps if you would like to skip ahead to another section. Let's begin with some really easy stuff. We're going to cover some basic arithmetic operators. Let's say we have a variable, friends. Currently you have 0 friends. If you need to increment a variable by 1, you could say friends, the name of the variable, equals the name of the variable again, plus 1. So the plus sign is the addition operator, and I think we do have a little bit of experience with that already. So if I were to print my variable friends, guess what? You now have 1 friend. We could also shorten this line of code. You could say friends plus equals 1. That would do the same thing. This is known as an augmented assignment operator. That will give you the same result. I prefer to use augmented assignment operators just because they take less steps, and I think they're easier to read. Now let's use subtraction. Friends equals friends minus 2. So of course minus is the subtraction operator. You have negative 2 friends, I guess. If you were to use the augmented assignment operator, that would be friends minus equals 2. There, you still have negative 2 friends. Okay, multiplication, let's change friends to, how about 5? Friends equals friends times 3. You now have 15 friends. Then the augmented assignment operator version of this would be friends times equals 3. So, again, you have 15 friends. Let's cover division. Friends equals friends divided by 2. So we have 2.5 friends. Somebody was cut in half. We have half a friend. Maybe it's just their legs or torso or something. Then the augmented assignment operator would be friends divided by equals 2. And the result is still the same. Now, exponents. Friends equals friends to the power of 2. So friends is currently 5. Friends to the power of 2 would be 5 times 5, which is 20. Augmented assignment operator version of this equation would be friends exponent equals 2. And again, friends is 25. Then we have modulus. Modulus gives you the remainder of any division. Suppose we have 10 friends instead of 5. I will assign a new variable, remainder. Remainder equals friends. The percent sign is known as the modulus operator. It will give us the remainder of any division. If I were to divide my group of friends by 3, we will have 1 remaining. I'll store the remainder within a separate variable. We would have a remainder of 1. It's kind of like in class when the teacher says for everybody in the class can go into groups of 3. Then there's always that one kid that's by themselves. That's kind of the same concept. We're dividing our friends into groups of 3. Then the modulus will give you the remainder. If we divided our group of friends into groups of 2, well, 10 divides by 2 evenly, so there is no remainder. So that is the modulus operator. It's fairly popular to use this operator to find if a number is even or odd, because it will divide by 2 evenly if that number is even. If the remainder is 1, that means that the original number is odd. Okay, so yeah, those are some basic arithmetic operators. Addition, subtraction, multiplication, division, exponentiation, then modulus. Now what we're going to do is cover some built-in math-related functions. Suppose we have 3 variables, x equals 3-point differentiation, and then...
Okay.
And modulus. Now what we're going to do is cover some built-in math.
Example
Related functions. We'll divide by 2 evenly if that number is...
Okay.
Division equals 3 point.
brother. Pickup brother. Division, okay. Making space first. Can you even build those? Oh, you could. Okay. I should do, I think.
Okay. 1, 4. Y equals 4. C equals 5. It doesn't matter if these are floating point numbers or whole integers. First is the round function. We have a variable named result. I'm going to round x. So there is a built-in round function. After the set of parentheses, we can add some value or variable to be rounded. So we will round x to the nearest whole integer, then print the result. So our result is 3. So that's the round function. With the absolute value function, we can find the absolute value of a number. Let's change y to be -4 instead of 4. We'll take result equals ABS, which means absolute value of y. The absolute value is the distance away from 0 as a whole number.
Absolute value.
Absolute value of -4 is 4. Let's change y back to 4. There's a built-in power function. Result equals how. Then we'll need a base and an exponent. What's y to the power of 3? That would be 4 times 4 times 4, which is 64. That's the power function. We can raise the base to a given power. The next two are really useful. Using the max function, we can find the maximum value of various values. What's the maximum value between x, y, and z? Then I'll just need to store this value. Result equals the max between x, y, and z. Well, the maximum value is 5. Otherwise, there's min. What's the minimum value between x, y, and z? That would be 3.14. Now, in this next section, we do have some very useful constants and functions from the math class, but we'll need to import the math module. 3.14. Now, in this next section, we do x, y, and z. Well, the maximum value is 5. Otherwise, there's min. What's the minimum value between x, y, and z? That would be 3.14. Now, in this next section, we do have some very useful constants and functions from the math class, but we'll need to import the math module at the top of our text editor. Import.
Yo, why is this so freaking loud? Okay,
For map, if you need the value of pi, you'll type the name of the map module, dot pi. And I'm just going to print this. Print map.pi. The value of pi is 3.14159 and a bunch of digits that come after. If you're working with physics, I do know that people use the constant e a lot. You won't be using e in this video series, but if you ever need access to it, just type map.e, and that will give you e, which is 2.71 something something something. I believe e is known as the exponential constant. If you need the square root of a number, let's say result equals map.sqrt, we can place a variable or a value within the square root function. Let's say we have x again.
Yep.
X equals 9. What is the square root of that? Or we do have between x and back. And next,
so fucking loud. What the fuck? I don't get it though. It's not even.